Alright, now we are back in question 2b. This is your differential equation, and then this is the initial condition here. Now, looking at this kind of problem, you will observe that this is in form of a linear equation. If you compare this, if you compare it with the y dt plus p of ty equals g of t. So you'll observe they have the same format. So you can see here. Now our p of t here is 2, your y is still your y, while your g of t is 1. So there are two methods you could use here. You can either use the integrating factor method, or you could just use or rewrite this in terms of putting all the y's on one side and all the t's on one side. In other words, what I meant is using the separation of variables method. So I'm going to use the separation of variables method since I like the method and I feel the method is kind of a little quicker in solving problems like this. Either way, any of them is quicker. It depends on how flexible you are with it anyway. So let me write my equation. You have the y dt equals, you have 1 minus 2y. I only brought this 2y to the other side here. So looking at this, I could bring this to this side. You have dy minus this 1 minus 2y equals dt. I'm applying the separation of variables. Now I've separated all my variables, so you have this and this at the other side, and then you would integrating this. You have, now many a times students make mistake in this area here. So what you'd observe is this is negative 2. So initially, if you want to integrate something like this should give you the ln of 1 minus 2y, now divided by the differentiation of this whole thing here. When you differentiate this whole thing here, you would have negative 2. When you differentiate it with respect to y, you should have negative 2. So whenever you've done it generally, you have ln of 1 minus 2y. Ensure to divide it by the differentiation of the term you have in that denominator there. So we have negative 2 equals your t plus arbitrary constant there. So I could easily cross multiply here. So what I have here is a ln of 1 minus 2y equals minus 2t, then times negative 2k. So I could represent that with another constant. Let me call that a. So ln of 1 minus 2y equals negative 2t plus a. So this implies that 1 minus 2y equals exponential minus 2t plus a. Now this is the same thing as b e to the negative 2t. So we do not forget that there is an arbitrary constant here. Now to remove the absolute sign here, we have 1 minus 2y equals plus or minus b e to the power negative 2t. And then this is another arbitrary constant which I could just call another thing. Let me call that c equals c e to the power negative 2t. So what I have all in all is 1 minus 2y equals c e to the power negative 2t. I only rewrote what I had here. So I want to make y the subject of the equation. So you have negative 2y equals c e to the power negative 2t minus 1. So this becomes y equals, you have 1 minus c e to the power negative 2t all over 2. Now to use this initial condition, it says when t is 0, so when t is 0, you have 1 minus c e to the power. When t is 0, this whole thing becomes 0 divided by 2. I'm told that my y equals 5 all over 2. So when this crosses out, so this one goes to 1. So you have 5 equals 1 minus c. So looking at this implies that c equals negative 4. So since my c equals negative 4 here, I could just come back here and rewrite this general solution here as y equals 1 minus, so since my c equals negative 4, so this becomes plus 4 e to the power negative 2t divided by 2. So this is the particular solution for this initial value problem.